position. Let's go to planning and hit plan and execute. And assuming everything is still running, the robot will then execute the motion plan to get you from point A to point B. So, okay, so this is a lot of fun, Alan, but why would you want this in a robot? This is something we can use to validate and verify the behavior of the inverse kinematic solver. Here's how all this fits together. Here's the next step. Using the camera and an object recognition library, we're going to identify and localize an object of interest in 3D space. Now, in that first video that you saw, we had a solution that its purpose in life was to identify red blocks. You have to start somewhere, right? So once we identify and localize that object in 3D space, we get on a topic a message with the point and orientation in 3D space where that is. You then take that point and you feed it as an input to the arm. You say, arm, I want you to be, I'm oversimplifying a little bit, I want you to take a position where you can pick up that block. The motion, the move it inverse kinematic solver then comes up with a motion plan to move the arm in such a way that it can put its greasy little fingers around that block. You have another command to close the gripper, and you have just solved for identifying and grabbing an object of interest in 3D space. So at the end of all that, as impressive as that is, it's not really very useful, but it is a building block, a step in the way of more advanced behaviors to solve real problems in the real world, using pretty much more or less off-the-shelf tools, existing packages and solutions that are out there right now. So as part of the ROS solution for Tossin Robotics, they've written some code in C++. There's one for block manipulation and block moving. And we're going to be working with that shortly. I don't have that demo ready today. I don't even have any blocks here right now. But working with Walter and his class, we're going to take those building blocks and arrange them in different ways to come up with new solutions.